Hello. So today we discussed about the thermodynamics, some basic concepts about thermodynamics. So at first we have to understand what is thermodynamics. Now thermodynamics is the study that relate between heat, temperature and energy. So basically it is the study to relate between heat, work and temperature and energy. So basically thermodynamics means it is the relation between work, heat, temperature and energy. That is, with changing temperature, how much heat generated, how much work is done, and how the work is related to heat, and how energy is produced. So this is all about thermodynamics. This is the basic concept of thermodynamics. Now, to study thermodynamics, we have three types of laws. So, laws of thermodynamics. Very briefly we are discussing these laws. Laws 1, that is first law of thermodynamics. First law of thermodynamics, what tells? It tells about the conservation of energy. Only the conservation of energy. Now we will discuss only the very brief concept about these laws, and later we will discuss more details. Second law, what tells? Second law tells about the feasibility of a process. Feasibility of a process. Suppose a process is going from A to B, then how this process is gone from A to B, how much feasible, that is how it is possible, is it possible or not, in what direction it possible, how much time it is possible. This is related to second law. Again, third law. Third law tells about the entropy. Entropy, and it denotes also the various thermodynamic properties, like it provides method of evaluation of thermodynamic properties. So what is thermodynamic property? The thermodynamic properties are like entropy, S, gives free energy, G, gives Helmholtz energy, which is denoted as A, enthalpy, H. These are all thermodynamic property. And internal energy, U. These all are thermodynamic property. So third law tells that this evaluation of these thermodynamic properties, like how to calculate entropy, how to calculate the Gibbs free energy. Mainly third law tells about that how to calculate the entropy. So we further discuss details about that law. And another law comes later, that is called zeroth law. What is zeroth law? Now zeroth law tells that if two systems in equilibrium, like if A is a system, it is equilibrium with B separately. Separately, A is a system, it is equilibrium with a system or state, something a state. It is equilibrium with B. Again, if B is equilibrium with C state, then it defines that this A will also in equilibrium with C. That is, if A is equilibrium with B and B is equilibrium with C, then it denotes that A also equilibrium with C. This tells about the zeroth law. Now we will explain later for details. Now we goes for the systems. What is system? What is surrounding? Now we have to understand first system. What is system? So system is a part of universe. It is a part of universe. How it is a part of universe? The system is part of universe that for which we study some different type of thermodynamic properties. Like if we consider a beaker, some different materials or some solution in there. So if we study about this, if we study about the thermodynamic properties, if we study about different thermodynamic properties of this state, so it is the system. That is, it is separated by a boundary, that is real or imaginary, separated by a boundary which is real or imaginary. So basically system is a part of universe. Basically system is a part of universe which we have to study, or for which the thermodynamic properties we have to study. This is the system. And surrounding क्या है? SURR surroundings is the other part of the universe, that is without systems other whole universe is the surroundings. So surroundings is universe minus system. This is called surrounding. So the states we have to study is called system, and other than the whole universe is called the surroundings. So surrounding means universe minus system, or we can say universe equal to system plus surrounding. So this is the basic part of system and surroundings. So we are discussing for system, surroundings and universe. So system is, what is system? The system is a part of the universe. System is the part of the universe that is selected for the study of thermodynamics. So system is a part of universe that is selected for study of thermodynamic properties like entropy, internal energy, enthalpy, Gibbs free energy, these properties. So it is a part of universe for which we study the thermodynamic properties. So it is a system, and system have a definite boundary. What is boundary? The boundary is a real or imaginary system that separates the system from its surrounding. So if this is a system, it has a boundary which can be real or imaginary. Real, what means? Real means if we put a piston like this is a boundary which separates these states from the other surrounding, and again it can be imaginary, that is we can imagine like that here is a boundary. So it's real or imaginary state that separates the states from its surrounding. This is surrounding. The rest part of the universe whole is called surrounding. So surrounding, the real or imaginary boundary separates the system from its surrounding, which is called the boundary. Now system can be of different types. System, that is thermodynamic system. Systems can be of different types, like homogeneous system. Homogeneous means same phase, uniform in all parts. That is, we can say also that same phase. So same phase means homogeneous means, like example, if we can give example like the mixture of gases. Mixture of gases is a homogeneous phase. All are gases, as this is a uniform mixture of gases, so it is a homogeneous phase. Again we say that miscible liquids, the liquid which are mixed fully, these are miscible liquids. Again we can say pure solid state, which is also a homogeneous mixture or homogeneous system. Now we can say about the other system, which is heterogeneous. Heterogeneous means not uniform in all parts, That is, we can say that different phases present in the system. Different phases can be possible in the system. So example, we can say that liquid with vapor, that is, vapor is gas. Again we can say mixture of immiscible liquids, mixture of two or more immiscible liquids, mixture of two or more immiscible liquid. If we mix two or more immiscible liquid, then it can form a heterogeneous mixture, that is, all the liquid are not in the same state. That also called the non-uniform mixture. Again we can say the mixture of solids, it also the heterogeneous mixture, that is different phases present in this. So these are the example of heterogeneous phases. Now we can study the different types of system, different types of systems. In which basis? Now, on the basis of types of boundary walls. Boundary walls, we mentioned that it is real or imaginary state which separates the system from its surrounding. So this is boundary, and depending on these boundary walls, the system can be of different types. What are those? One is open system. Open system means it is open to the surrounding. This is as simple as that. Open to the surrounding means if we put a beaker and here is any type of liquid or something in system, so it is the system. There is no boundary. There is no boundary, only a system without a boundary. That means it's open to the surrounding. It is open to the surrounding. If it is open to the surrounding, then the mass of the system, its mass m and energy, both can be changed between the surrounding. That is, if this system is open to the surrounding, then mass and energy can change with the surrounding as it is open. So it is called open system. What is the example? The example is very simple example. Water in a beaker. Water in a beaker. If we put water in a beaker, then the water in presence of sunlight, it can be heated or it's vaporized to vaporize. It can vaporize, so its mass will change and energy also changed. So mass and energy both can change in this case. So it's an example of open system. Now what are the other systems? There is one system is closed system. Closed system. What is this? Closed means there is some boundary between the system and the surrounding. If this is a system and this is the boundary, that is, here is a real boundary, not imaginary. In open system we can say an imaginary boundary, that is not real. That's why mass and energy can exchange with the surrounding. But here in case of closed system, there is a boundary, like any piston or any some kind of plate. So it can be a boundary, and it separates the system from its surrounding. So if this is a boundary, then the mass of the system cannot change with the surrounding. That is, mass exchange not allowed. Mass exchange not allowed. But energy can exchange. Like we say that if we put some water in a beaker and we closed it, so like with some plate, then the mass of water not change, but water can be heated up in presence of sunlight. So heat exchange can occur, but mass never change. So it's a closed system. So energy can be exchanged, but mass cannot be exchanged with the surroundings. Example, what is the example? The example is liquid in equilibrium with vapor. Equilibrium with its vapor. Like as you said that if water put in a beaker, water like it's water, and there is some plate or some piston, then in presence of sunlight, or if we put some heat, then the water will convert it to vapor. So liquid and vapor conversion, this equilibrium, liquid equilibrium with vapor. So this is the state with closed system, where mass cannot change, but what is energy will change. Now the other system is isolated system. What is isolated? The system is fully surrounded with an adiabatic wall. So what is adiabatic? So this is the system, and it is surrounded by an adiabatic wall. So what is adiabatic wall? The adiabatic wall means heat cannot be transferred through this wall. Adiabatic wall. The adiabatic walls means heat can't be exchanged through this wall. So heat cannot be exchanged, and heat cannot be exchanged, and mass also not exchanged, as this boundary is present at adiabatic wall. So here mass and energy both are not exchanged with surroundings. Mass and energy both cannot be exchanged with surrounding. What is the example? We can say in our everyday life that is thermoflux. If we put some boiling water or boiled water in thermoflux, it will remain as almost in same temperature. Although some heat will transfer, but we can say it's a adiabatic wall and it's an isolated system. So boiling water in a thermoflux, boiling tea in a thermoflux is an example of isolated system. So these are the systems which are related, which are actually under the thermodynamics.